and finish the last of the quadratic stuff. Okay? So this is the last part of this chapter, meaning next week we're going to have a test on it. Yay! I haven't decided yet. I'll let you know.
Yeah, that's what you know. Shh. She's asking me how to use a calculator.
Okay. So, what I missed yesterday kind of works into what the other part of what I'm going to talk about today, and that is squaring a binomial. Now, I know some of you went over examples of this in the book, so maybe you already know how to do it, but just in case, I'm going to go through this. So if I have my question here, x plus y squared, what does that actually mean? What does that tell me?
That there will be two of the x plus y's to be x plus y with another bracket and the same thing, x plus y. Or just 2x plus 2y.
What? I don't know what's happening right now. I think it's just way off. But yes, the x plus y squared means there's going to be two sets of brackets there. So x plus y times x plus y. Now if we have this, we can solve it just like we did yesterday. So x times x is x squared, x times y is xy, then y times x is still xy, and then y times y is y squared. And then when we simplify this, we end up with x squared plus 2xy plus y squared. So looking at that, there's actually a much easier way to solve these rather than going through this set of steps each time. Mind you, it's only 3 steps, but there's still an even easier way to solve it. Because the last two terms, the first and last term, will always be the first one here x squared and the second one squared, right? So if this were 4, it would be 16 here, and if this was 3, it would be 9 here, right? Just square those two terms, and that's your first and last term. Then the one in the middle will always be 2 times that times that. Okay, so it simplifies the whole idea. So let's say, just as an example, I had, minus 3 squared. The first term will be x squared. The last term will be plus 9, right? Minus 3 times minus 3. And then the middle term will be 2 times x times negative 3, which is minus 6x. And you can follow those steps just to shorten your work a little bit. Mind you, if you forget how to do this, there's no problem showing all of this to get your answer. That's fine. It's just a little shortcut that might help. Okay? So let's try this one, for example.
So how do you get the middle number?
2 times the 2 terms multiplied together. So in the other case, it was negative 3 times x times 2. Or x times y times 2.
Yeah, me
Are you finished? I just did this one. Yep. Write an expression. It's just finding an expression for this. An expression with n being term. So if I say n equals to 4, I should get the answer of n. But n equals to 2, I should get the answer of 12. So it's
just
well, one expression will work.
It just takes we have a key from 6.
Okay. So, what's my answer here?
Where did you get the 46?
6 times 6. And the 12 comes from 6 times x times 2. Okay, fair enough. So now, I already did that one. So here is the next part, these ones here dealt with expanding, like with what we started with. This one deals with factoring. But this is a special kind of circumstance that we call difference of squares. So the difference of squares happens anytime you have a square term here, and you're subtracting. So to factor a difference of squares, you have to do what I say there. So x squared minus a squared is equal to x minus a times x plus a.
What?
X squared minus a squared is equal to x minus a times x plus a. It's just a rule for factoring that you'll have to memorize. Now I can show you why that works by taking this here and expanding it. So if I expand this, I get x times x, which again is x squared, x times a positive a, so that's plus ax, then I have negative a times x, which is minus ax, and then negative a times a, which is minus a squared. But when I have plus ax minus ax, those cancel each other out. So all I'm left with is x squared minus a squared. So it's just a rule to help you factor that sort of situation. They have rules for all kinds of things. So difference of cubes, difference of squares. They have different rules like that to help you with those little situations that you might run into. Now, if you had an example like this, you could actually follow the same method we went to before, that we, one number or two numbers that multiply to get this and add to get the one in the middle. But there is nothing in the middle. So the two numbers you multiply together will have to add to get 0. But you can follow the same steps as you did before. But again, this is just another shortcut to help you solve this kind of problem. So let's put it to use. So, I don't know why. Let me change that for a second, because obviously that shouldn't be that way. There we go. So I have x squared minus 9, and I want to factor that. I want you to factor that, x squared minus 9. Difference of squares. I want you to factor that.
Make it bigger.
No, well, yes, I guess
So
in this
is it
case.
like x minus 3 in brackets x plus 3?
Yes.
I have it.
Oh!
What?
Wait, so we have to put it on like in the bracket, like.
Factor it, yes.
Yeah.
What do I do? X minus 9? X minus
I'm the
9.
genius.
You take this term here is your a squared term, right? So in this case, if a squared is equal to 9, what is a? 3. So 3 is what's going to go into your brackets.
So it'll be
Because
X
that's
Because 3 times 3 equals.
because the square root of 9 is 3.
So you always need to find the square root of the second number.
Yep. So it's x minus 3, x plus 3. You take the square root of both the first and second term, and then those are the values that go into your brackets. One with plus, one with minus. With me so far?
Easy.
That doesn't belong. That was me making a mistake when I made your lesson. Good.
Wait, so what did you mean to 16? Just plus and it's 16.
How did I get closer?
Remember, you take the square root of your first term, square root of your second term, and those are the values that end up in your brackets. So, our answer then?
4x minus 7, 4x plus 7.
4x minus 7.
Is it always the same, just like plus?
I mean, I could write, if I really wanted to, I could put plus 7 first and minus 7 second. That doesn't matter.
Yeah,
But as long
what
as
I'm talking about
one has
is
to be
there is,
plus.
like, the same numbers, just.
One has to be plus, one has to be minus. Exactly.
Okay, then I can.
So we got this? Make sense? Now comes the hard part. Solving quadratic equations by factoring. So, with all that we've done up to this point, we've learned how to expand, right? We've learned how to factor. Now we're going to use that to help us by finding a solution to our quadratics. Now, for these particular examples, okay, for the most part, your equation is going to be equal to 0. However, there will be some examples where it's equal to a number. It might be equal to 20. In that case, that means you have to rearrange your equation so that it is equal to 0. If it's not equal to 0, we can't solve it with this method. Okay, so it has to be equal to 0. So this is how it works. We're going to take the left side of our equation here, and we're going to factor it into, our brackets, and that's going to give us our solution. So for this first one, it's actually pretty easy. From each of these, I can factor out an x, because this is x squared, this has an x, so I can take an x out, right? So I have x, then in front, I put my brackets, and then from here I have 1x left, minus 3. Right? So I'm not using the rules we had before to factor this one, just basic factoring. But now once I have this is where I get my solutions from. Now what you can do is you take each part here. So if we wrote out the question and we had 2 sets of brackets, like we normally have done, and you're going to take each set of brackets separately and set them equal to 0. So for example, with this one, I'm going to have x is equal to 0, and I'm going to have x minus 3 is equal to 0. I'm going to take the 2 parts, take them apart, and then set them both equal to 0. Because if you think about it, if I want this here to be equal to 0, either this has to equal 0 or this has to equal 0. Because since we're multiplying, the only possible way to get 0 when you're multiplying is if you multiply by 0. Because if these equal any non-zero number, you're going to get a non-zero answer, right? You know what I mean? The only way to get 0 when you're multiplying is to multiply with 0. Which means this has to equal 0, or this has to equal 0. Okay? So my first solution is here. Very straightforward. And then this, I just have to solve for x. Yeah?
3.
So I bring that over, right? Add 3. So x is equal to 3. So with quadratics, you're going to have 2 different answers. Okay? Sometimes your answers might end up being the same, which is possible, but you will always have 2 different answers. So in this case, 0 and 3 is my solution. Okay? Does that make sense so far?
So far.
So far, so good. And let's try this. So, I have x squared minus 7x plus 12 equals 0. So the very first thing I need to do is I need to factor this.
X.
What?
Use X.
Well, we're going to factor it using the method we did yesterday. So two numbers that multiply to get 12, add to get negative 7. And the same way we did last time. I'll give you a couple minutes to do that. Oh,
No, then you have two brackets. Now separate the two brackets.
so first things first, what does this factor to?
In brackets x minus 3, then in other brackets x minus 1.
Exactly. So we set that equal to 0. Yes, you have to write the 0. Because now that we know this is equal to 0, that's what lets me do this part. Where I take my brackets and set each one by themselves equal to 0. I split them up. So, this tells me that x is equal to 3, and this tells me that x is equal to 4.
And it's always 0?
It will always be equal to 0. If it isn't, you have to make it equal to 0.
Well,
Just by moving
it's
the
just-
numbers to the other side of your equation.
Right, so 1x is 3 and 1x is 4.
Yep. Because quadratics look like this, if you don't know. So what we found are two solutions. That's what we're actually finding. Just we don't actually graph them yet. So I guess, well, for this particular example, it would be more like this, right? 3 and 4. But that's what we're actually doing. Is once we get into graphing these things, this is what they look like, and we're finding these points. That's what these solutions mean. But we don't cover that yet because we don't get into it later. Where we get into it later. So, any other questions? So this is an example like I was talking about, where it's not equal to 0, so we're going to make it equal to 0 first. And how do I do that?
Remove the 12.
Remove the 12, and I do that by doing what?
Minus 12?
Subtract 12, exactly. I just have to bring this number to the other side of my equation by subtracting 12. So, x squared plus 6x minus 16 is equal to 0. Now I follow the same steps. Yes, negative 4 minus 12 is negative 16.
Okay.
And aside from this, that's about as hard as it gets.
You just need
That's
the
so
number.
hard.
You just have to move everything to one side of your equation. That's all.
And then find 6. I guess 16.
And then factor it just like you normally would. So two numbers multiply to give you negative 16 and add to give you 6.
It's 8 times 2, that means it'll be x plus 2, then x minus 8, and then...
Almost. Because it's positive 6 in this example. That example, it's negative 6.
Oh, then it's x plus 2, then x plus 8.
X minus 2, x plus 8.
Yeah.
Like, I'm losing time of my hair just because of this stupid chair.
I lose my pen.
Yeah, I'm saying like this one. Doesn't matter which one you put first.
I lose one of my legs.
No, you can put x plus 8, x minus 2. It's still the same thing. But the plus has to be with the 8, and the minus has to be with the 2. Good news, everyone. The laptop key came back. The key for the laptops was missing.
Didn't change it.
No, we got another one. We didn't change it.
Another one.
So what is our solution to this one?
2x equals 2 and x equals 8. No, 8.
Negative 8.
Why negative?
Well,
Because I bring that, so I subtract.
this kind of makes sense.
It don't make sense? Huh?
It does kind of make sense.
It does kind of make sense.
Yeah.
So, are there any questions about this?
I don't get the answer.
Well, I'll come back to you later, Carlos.
Nothing makes sense.